Country Multiplex Pricing, CMP, is here. What you need to know to minimize your MLC costs, brought to you courtesy of MVS Solutions. Today's presenter is John Baker. John Baker has over 20 years in the IT industry as both a customer and consultant, including 15 years specializing in mainframe performance at a large international bank and 6 years in enterprise I/O performance with IntelliMagic. As a customer, John designed, implemented, and maintained many critical projects such as WLM Goal Mode, GDPS, data mirroring, and merging data centers. He has extensive experience with many performance analysis tools and techniques at the hardware, OS, and application levels. As a consultant, John has assisted many of the world's largest data centers with their ZOS performance challenges and held subject area chair positions with CMG for both storage and capacity planning for several years and is managing the System Z track for CMG 2016. John has hosted many sessions at CMG, Share, and IBM conferences, as well as several regional user groups. John is the Principal Z Performance Specialist at MVS Solutions, the creators of ThruPut Manager. Before we begin, we would like to encourage you to submit questions throughout the event via the Q&A box on your webinar toolbar. The speaker will address these at the end of the presentation. There is a survey after this webinar for you to complete. We thank you in advance for your feedback. Also, please note that presentation slides and recording will be available post-webcast at www.share.org. I would like to now turn the web over to today's presenter. Please go ahead, John.
Thanks, Melanie. That was a very lofty introduction. For the techies in the room, I am a mainframe performance guy. That essentially sums it up, but thank you very much for those words, Melanie. I'd also like to thank Melanie in particular and Share, the organization Share, for sponsoring the webinar today. We hope you'll find this useful. I want to talk about country multiplex pricing and monthly license charges in general. That's what MLC stands for. Essentially your software costs, which are the biggest line item in your data center today. And we'll talk a little bit about ThruPut Manager as well and how that can help. So, very simple agenda, a brief overview of how subcapacity pricing works. For those of you not aware, the dreaded, shall we say, 4-hour rolling average or rolling 4-hour average. I hear those terms interchangeable. They both make sense to me. And something I'll call peak versus peak. When I talk about my peak, well, which peak am I talking about? We'll talk about that. How monthly license charges pricing is calculated by IBM, how they do that. A little bit about soft caps. Many of you might be using that option today. Talk about how those work. Then introduce the CMP, countrywide multiplex pricing option, how that works, comparison with traditional subcap pricing. Finally, what I'll call the catch. You know, there's no free lunch. There's never a free lunch. Why shouldn't everybody just automatically turn on country multiplex today? Well, that's not necessarily always a good idea. And then we talk what more can be done, and this is where we go into a little bit about some of the other options that you can do, specifically with ThruPut Manager, to control your monthly license charges, lowering your baseline for CMP. Should be lots of time at the end for questions. We always enjoy taking your questions. So when I started the research for this, I just had to go back and look at subcapacity pricing. Has been with us for quite some time. We're coming up on 16 years. Very nice, if I might say, a democratic offering from IBM. For those of you unfamiliar, traditionally, prior to capacity pricing, you were billed based on the total capacity of your machine, whether that's MIPS, MSUs, you know, whatever term you like to use. Essentially, if you had a 10,000 MIP capacity machine, you were billed for 10,000 MIPS worth of capacity for your software. With subcapacity pricing, the idea is this is a consumption-based metric, and moreover, based on the 4-hour rolling average, which allows you to have brief peaks in consumption that will not necessarily directly affect your bill. So speaking of that term, the 4-hour rolling average, the idea of that is a consumption measured in millions of service units per hour, or MSUs per hour, not to be confused with the service units, SRM service units, that we see in our workload manager records. MSU, millions of service units per hour, is a software measurement specifically for billing. This is not a capacity planning number for the machine. The idea of the 4-hour rolling average is allowing for short-term peaks. Just as the name suggests, it is exactly that. It is an average consumption over the previous 4 hours that obviously continues to move forward with time. Specifically, it's calculated and updated in each LPAR on a control block every 5 minutes, and then rolled up at the hour and then at the 4-hour average. And for those of you SMF folks in the room, that's the variable there, SMF 70 LAC. If you're looking at your Type 70 records through your regular SAS reporting or any tool that you might use, that's the actual rolling 4-hour average value on each LPAR. Of course, the monthly peak of that number is what's used for your billing. So speaking of peaks, I mentioned peak versus peak in the intro. When you're talking about a peak, what are you talking about? If you look at the example here, at about 10 o'clock in the morning, I see a CPU peak. This would be equivalent to the highest utilization on the machine. We can see the consumption here broken down into batch online systems. This is shown in MSUs, but it could be, as I mentioned, it could be MIPS, service units, CPU time, whatever you like. But it's the highest utilization. So at that time, the concern is very likely going to be performance of the workload, not necessarily billing. The 4-hour rolling average peak occurs several hours later, about 3-4 hours actually in this case. And that's what you're billed on. And if you look at that specific hour, about 1 o'clock in this example, the actual consumption at that time is below the average. In fact, it's been below that average for about a solid hour. So the point I'm making here that if controlling this 4-hour rolling average is really the goal, you can't take action at 1 o'clock when you reach that peak, which is what capping does, by the way. You need to be proactive. You need to actually go back the previous 4 hours, all the way back to, say, 9 o'clock. And what you want to look at is all of the work that ran in the previous 4 hours, and not just what is necessarily what we might say driving the peak. What's driving the peak would say be the largest workload. In this case, most of the time it looks like it's the online. But really anything at any priority in any service class consumes CPU, which means it generates MSUs and contributes to the 4-hour rolling average, and that should all be considered. Now on the money side, if you're performance or capacity people like me, sometimes you don't deal with dollars. Not really our job. We measure things, we do capacity planning, we do tuning, and we may very well even run the SCRT report to calculate our consumption, but then we send that off to finance, and that's up to them. This is an example of what you're looking at in terms of scale. Now, these numbers have been slightly changed to protect the innocent, but trust me, they are reasonably representative of what you would see in a typical advanced workload license charge environment. And the area that I have highlighted here gives an example of a peak of 1,000 MSUs. So if you had a monthly 4-hour rolling average peak of 1,000 MSUs, you had the products listed here because subcapacity pricing is done by software products. You're charged a rate for ZOS, you're charged a rate for DB2, CICS, IMS, MQ, and there are others not listed here. But each of those has a value. You can see at the very low range, $4,000 for ZOS, $5,000 for DB2, $6,000 for KICS, and so on. And then they're accumulated. So what we call the incremental rate, so that is the tier rate at each level, the incremental rate goes down, which is also democratic, if you will. The larger you are, the more capacity that you consume. IBM gives you a better deal on the MSUs as you get larger and larger. But because they are cumulative, this adds up. And as in the example here, you're talking about over $650,000 per month for that, what we would call that software, which says ZOS, DB2, CICS, and so on, at 1,000 MSUs. That's going to be my cost. My average rate, of course, is $666 per MSU because I've got 1,000. But my incremental rate is at this level 5 that's highlighted, 330, which means reducing MSUs at that level. That's the dollar amount that I can expect to save for every MSU that I can reduce, until I were to go down to, say, the next tier. If I go down to 875 in consumption, then my rate goes up. So anyway, the point of this slide is just to give you an idea that we're talking about a lot of money. So for performance and capacity people, where traditionally all we've been concerned with is performance and capacity, there's good reason for here to work with our finance people to reduce consumption where we can. Now, further calculating MLC, I mentioned that it's billed based on software product, so ZOS, DB2, CICS, and so on. This is also done by LPAR. So what this chart is showing, 4 LPARs on a machine, and the scale on the left, the dollar value, all I did was use the initial 3 MSU rate. So we're not talking about the absolute dollar amounts here. What I'm trying to show you is a relative comparison of cost based on software stack. So if I look at LPAR 1 versus LPAR 4, my all other values being equal, my MSU cost is much higher. And a key point to remember is it doesn't matter if you're using the software product that is licensed. And by that I mean if I have a batch job that's running on LPAR 1, even if it never uses IMS, even if it never uses DB2, the MSUs that it consumes are billed. IMS is billed, DB2 is billed for the total consumption on the LPAR, simply because the product is licensed there. So when you look at it in this way, it's also useful to be able to manage your consumption on an individual LPAR basis, or perhaps groups of LPARs, putting LPARs together into what I would call LPAR sets, and we'll talk about that a little bit later, where the rate per MSU on those LPARs could be different from others, and I might want to manage the rolling 4-hour average on those LPARs differently from others. So we'll get into that a little bit later as well. Briefly, soft caps, how soft caps work. Many of you likely use soft caps today. It's a pretty good idea to control costs. The idea being when you have a soft cap in place, this is a defined capacity which works on a single LPAR, or group capacity which works on multiple LPARs, is that if the 4-hour rolling average exceeds the soft cap level, IBM will not bill you for that high rate. It bills you for the 4-hour rolling average peak or the cap limit, whichever is lower. Now again, there's no free lunch. If the 4-hour rolling average exceeds the cap limit, the LPAR or group of LPARs will be capped by PRISM, and this can greatly affect performance. And we'll talk a little bit about what that looks like here. So here we have a machine with 2 LPARs. The red and green bars represent the consumption of the 2 LPARs. And as you can see, starting from the left, and the cap level is that black line across the middle, the consumption for the LPARs can freely exceed the cap level as long as the 4-hour rolling average, which is the dark blue line, does not exceed. As soon as that happens, Gary indicated there, the 4-hour rolling average now exceeds the cap, then these LPARs are going to be capped. Essentially, WLM informs PRISM that you need to cap these now. And what this does is it defers the dispatching of logical processors on the LPAR to physical processors. So it does slow things down. And the issue with this is, firstly, it's indiscriminate with respect to workload. The entire LPAR is capped. You're not specifying what workload, even though, of course, WLM will do its best. But WLM doesn't have access to the physical resources. It only has access to logical resources. Sometimes we call this hitting the wall. You know, you're running along just fine. You can see the LPARs consuming up near 275 or so, and then suddenly they're capped. Looks like that's around 220. So it's very much as if suddenly the applications are in a smaller machine. This generally causes the phone to ring, applications run slowly, and quite often the result is that the cap needs to be raised. in order to preserve availability, because you can see here that the 4-hour rolling average continues to rise. So you're capped for quite a long time. In this example, it's a couple of hours. That's usually tolerable. Some other limitations of capping: an LPAR cannot be in more than one capacity group. But for business purposes, you might want to actually do that. I mentioned the software stacks earlier. So group capacity, a great idea. I can put a number of LPARs on a machine together in one LPAR group, provide a group limit for those LPARs. But for business reasons, I might want an LPAR to be in another group at the same time, and you simply can't do that. So we do have a solution for that. I'll talk about later. So now just to introduce subcapacity pricing. Announced about a year ago now, even earlier, I think it was last spring, and the planned availability date of October 2nd. I remember when that date came, I was kind of looking around, I was going to the conferences, said, okay, I'm looking for everybody jumping up and down on this. And I didn't see a big fanfare necessarily from IBM at this announcement. But the idea with subcapacity pricing and country multiplex pricing specifically, this is again what I would say a more democratic approach, essentially allowing you now your applications to span machines. So you saw the tier earlier with the dollar amounts on it, the $600,000 level, and if you recall the numbers, they essentially went up to, if you look at this table, they went up to level 7. At 1,976 and higher MSUs, that was the incremental rate that you will pay for all MSUs all the way up to the maximum capacity of the machine. And then when you went to another machine, you would start over at 3 at that very high incremental rate and work your way up again. So this can be pretty expensive when you have multiple machines. What Country Multiplex allows you to do is combine those MSUs. So effectively, if I have DB2 on one machine and I have DB2 on another machine, I'm going to combine the combined 4-hour rolling average for all of the LPARs where DB2 is licensed. And that total number in MSUs, that 4-hour rolling average, is going to be my bill. So this is definitely a good thing. You don't necessarily have to be a massive environment to take advantage of this. You really just have to have more than one machine within the same geographical environment. And of course, the larger you are, if you have multiple machines, multiple data centers, certainly an advantageous option. So why not just go? Well, as I said, the good, it does lower the incremental cost per MSU on growth. Does allow one large tier for all the machines in the same country. Also eliminates some of the things we used to do. I won't even say used to do. Some people still do it today, where we would say to IBM, yeah, this is a sysplex where we're running a sysplex workload, and it wasn't necessarily so. Creating artificial sysplexes. I know Cheryl Watson refers to these as shamplexes. There's no need for that anymore. I can see that option actually going away with CMP because you simply don't need it. But some conditions, the hardware must be relatively current, Z196 or newer. And the key point is that your price does not go down when you switch. And IBM will tell you this quite clearly. The purpose of country multiplex pricing is not to lower your bill today. They do need to maintain these margins. What it does do is lower your bill for growth. So additional MIPS or MSUs that you grow down the road are charged at this lower incremental rate. So it's absolutely a good idea in the long run, but don't think that you switch immediately and your bill goes down. And this, of course, is what we'll call a catch, is your initial price is based on your current existing monthly license charge. And more specifically, when you say to IBM, okay, we would like to switch to CMP now, among the contracts and the lawyers involved, they will ask for your last 3 months of SCRT data. And they will look at those 3 peaks and they will average them. And from that, they will come up with what we call the baseline. And this baseline value will be what your initial charge will be when you switch to country multiplex. And there's a multiplier that's derived from that that is present based on current rules forever. They may change it down the road, but as far as I know now, it's always there. You have this one-time change. So, of course, all this means is if this 3 months happens to be relatively high, well, this is what you're going to be based on going forward. So the short answer that we have at the bottom line here, lower your baseline first. And don't take my word for it. Cheryl Watson is telling people this. A lot of other people way smarter than me are telling people this. It's just a good idea. Obviously you want to switch, but the best thing that you can do for your organization is to first go through some effort to lower your 4-hour rolling average as much as possible over this 3-month period, and then that most recent 3 months, that's what you send to IBM, and that's what you use as your baseline. So now I want to talk a little bit about ThruPut Manager automation and how we do that. But firstly, just an introduction for those of you not familiar with ThruPut Manager and what it is. ThruPut Manager is enterprise software. It runs on z/OS. It's very tightly integrated with JES2 and the operating system. We have APIs to WLM and Prism to give us information. Logistically, it runs as started task. We've been in business, I think it was mentioned in the intro there, for quite a long time. It's the only thing we do in this area, about coming up on 30 years now. The primary benefits of the automation of ThruPut Manager, standards enforcement, classing, limits, infinities, things like that, essentially providing independence from what your users may code in their JCL. The service level manager, we'll talk about that. That is what we sometimes refer to as the engine of ThruPut Manager automation that makes all the decisions about what work should run, when and where and how. This provides optimal loading, improves overall throughput, automated classing and initiators, balanced LPARs. That's really a performance-based improvement that's part of the automation. And then the automated capacity management function, this is really what we've been talking about so far. This directly deals with the 4-hour rolling average and reducing your software costs. And this works with or without soft caps. So just briefly on the service level management core component, what SLM does, among many things, but in a nutshell, is every 10 seconds, SLM will analyze the utilization of the machine, the utilization of the LPAR, the current performance of the workload and the importance of that workload, and the required system resource or affinities. Does this job, for example, that's about to start, what does it need? It needs to run where DB2 is. Okay, well, it'll be aware of that and make sure that it goes to only LPARs where DB2 is available. We put all the work into a single queue, which is another very interesting and powerful approach. So you continue to submit your work as you do today in its normal classes through the scheduler or manually or otherwise. And after analysis, we put the work into a single queue, and it's ordered by business importance, by urgency. And when you're not busy, you don't care. Everything just runs. It doesn't matter about the priority. But when you get very busy and you get constrained, this ensures that the most important work, the critical work, always runs first. And this is constantly adjusted, as we said, every 10 seconds. So based on workload demand, I have new jobs coming in. 10 seconds later, I have other jobs starting. I have other jobs finishing. What is the utilization right now? What are the CPU delays that are being experienced right now? And we're constantly adjusting the number of initiators that are active, because we automate the initiators, and whether or not a job should, based on its performance goals. They're also based on cost goals, and we'll talk about those in a moment. The effect of this is to avoid overloading of the machine. It considers capacity changes. So if you change, if you turn on engines, change the weight, any soft capping, SLM is aware of those and will adjust accordingly. And the result is that you get balanced systems that can do more work. All your applications are more responsive because the system's not overloaded. This is particularly important with the new hardware, such as the Z13. I'm sure you've seen a lot of sessions on processor cache and how overloading this machine can cause a lot of problems, even though it is a faster core. And of course, this allows you to defer upgrades. Next couple of charts are just from a recent trial. we did in the U.S. in an environment with two LPARs with very different characteristics. One of these, I can tell you, had a weight of about 2%. The other one had a weight of about 12%. And the problem that this environment had was they run the batch on both of them, but whether they were using WLM initiators or JES2 initiators, the balance never seemed to work. You can't just set a static number of initiators. It doesn't work because some jobs use more CPU than others. And the result was, what we're looking at here is the utilization, by the way. You can see the blue LPAR is pretty much consistently at 100% on the left. The red LPAR was bouncing up and down. If a job happened to land on the blue LPAR, sys-A, it ran very slow. It took forever to get done. If it ran on the other LPAR, okay. But it was somewhat random, and critical jobs were not getting done in time. So after they implemented SLM on the right, we ran a number of nights. What I have in the times at the bottom here are many consecutive nights of running. But you can see, of course, that the utilization is very nicely balanced. This results in far better performance, not just for those jobs, but for every application on this machine, because the utilization is well in hand. We're not underutilizing the machine. We're running just the right amount of load. And I'll tell you another thing. They did throw me a curveball, because towards the end of the test on the right, they actually changed the weights on the LPARs to see if that would affect things. And SLM just adjusted. 10 seconds later, it realized that the capacity had changed and adjusted the number of initiators and adjusted where the workload should run and kept on moving. This chart is from the same data and simply giving another view. As opposed to looking at the utilization of the machine, this is actually measuring the average execution time of all of those jobs. And I can tell you there are about 5,000 jobs in each run. So clearly before, things were just taking much longer. This is almost directly attributed to that utilization problem. And the number of runs, we did 6 runs after with ThruPut Manager. Much better execution time, much more consistent. And specifically, I'd point out in the anomalies there where it did seem a little bit higher. Even though it's better, I did wonder about it. And when I looked closer at the data, I found 2 things. In 2 cases, the service units were higher, meaning we did more work. So, of course, it took a little longer. And in the longest example in the middle there, there was a DDF transaction looping for 12 hours. And you know how that can sometimes bite us. That was chewing up about 25% of the capacity. So we were pretty pleased with that result, that we still got the work done faster. Okay, so that is performance, but we're going to talk about automated capacity management now, which deals with cost. So I've mentioned how ThruPut Manager will measure utilization, performance, CPU delays, things like this, in order to optimally load the LPAR and the machine overall to get the most work done with the least resources. But we also look at any existing soft caps. If you've got defined or group capacity today, we'll be aware that they're there, we'll be aware of those limits, and we can work with those limits. We're also aware of the current 4-hour rolling average on each LPAR and on the machine. We calculate this ourselves frequently. We're aware of the current CPU consumption, so this gives us an idea of the trend too. We're not just looking at 4-hour rolling average, but are the peaks heading up, or are they heading down, so we can be proactive in our approach. And finally, you can have installation-specified 4-hour rolling average targets. And what this means is you may choose to not use a cap. You may choose to simply specify an MSU number, and we can work with that number independently of the cap if you have one, or without a cap at all. So just logistically, how ACM works. The idea here is, unlike capping, which I mentioned earlier, limits an entire LPAR and can indiscriminately constrain all the applications on that LPAR. What ACM does is allow you to specifically decide, first of all, what workloads are even eligible for constraint. So within the ThruPut Manager policy, all the jobs are grouped into what we call service groups. These are not unlike your WLM service classes that you have today. There are groups of jobs that are categoried, put into categories rather, based on application, based on business importance, and so on. And additionally, you will specify, is this group of jobs eligible for capacity management? Critical work, you would very likely simply say no. It has to run fast full speed all the time, leave it alone. That's no problem. For most of your low and medium priority, you might say, yes, it's eligible sometimes. And the sometimes is the next step. So when? When would I constrain these workloads? Well, this is decided within, again, the ThruPut Manager policy and a given 4-hour rolling average target. I'll show you in a minute how we calculate that target, but it does not have to be a single value, like a cap. You can have varying levels where you decide to constrain workloads. And then next, well, how will I constrain those workloads? You have options there as well. You can simply hold selection. If a job was eligible to start, you may say under certain conditions, no, you're not going to start right now because I'm not happy with the current conditions, the current 4-hour rolling average, so I'm going to ask you to wait, very much as if you would hold a job, except this is done automatically. Or if jobs are already running, we have automated resource groups. This is all under the ACM control, but in a nutshell, what we do is you create a number of workload manager service classes with resource groups attached to them, and those resource groups will have maximums that you've determined and varying maximums, so varying levels of constraint. Typically 5 is a good number, and you might say that one constrains to, say, 30% of the capacity of an LPAR, maybe another one constrains all the way down to 3%. You can do it that way. You can do it with service units. You can do it with CPU, whichever you like. But the idea is that you have varying levels of constraint, and then ACM has the ability to move workload into those resource groups depending on the conditions to constrain it. And that's, of course, the last point. Well, how strictly do I want to constrain? Do I want to stop it completely? So we talked about holding or concurrency. You could say this group of jobs, maybe normally I let them run, say, 20 concurrent jobs, for example. But under these conditions, I want to limit them to 10 or 5, maybe 0. Maybe I want to stop all selection of a certain group. Similarly, with the resource group capacity, you can decide just how severely do I want to slow things down. A very small service units or percentage of the LPAR, or relatively broad, where I'm going to take a lot of work and just slow it down a little bit. But the point is you can control this variably, and this is done automatically, and this is with or without soft caps. And this table is an illustration of some examples of how you might implement that. We have this we have this concept we call capacity level, 1 through 5. And these are equivalent to your current limit, which may be a soft cap or maybe a specified MSU value. That's capacity level 1. So in the example here, I've said my limit is going to be 1,000 MSUs. And maybe I have a cap at that level, or maybe I just specify a number, either. But that's my limit. Now with capping, that simply says at 999, I do nothing. I'm still running full speed. And at 1,000, suddenly I cap the machine. This is a very binary and I would say often painful approach, because you're going full speed and then suddenly you're in a smaller box. It's actually even worse than running a machine all the way to 100%, because at least as you approach 100%, you're going to gradually slow down. In this case, it's not the same. So with capacity levels, you can say, I can have these percentages here, and I've got the 80, 85, 90%. Now those percentages are also customizable. So you can decide exactly how early or late you would like to begin constraint. But the point is getting back to the earlier chart of the need to be proactive. I can't wait until I'm at my 4-hour rolling average peak to take action. It's too late. I need to start early. And that's precisely what ACM does. So when your 4-hour rolling average reaches the values in the example here, so for example, my 4-hour rolling average reaches 800, capacity level 5 is triggered, and the rules say, well, what do I do at capacity level 5? Well, my policy in this example says I'm going to move my low priority test batch into a resource group from its existing default service class. I'll move it to a discretionary service class with a resource group maximum of 15% of the LPAR. This is going to apply some mild constraint to that workload, leaving all other workloads unaffected, but having the effect of gradually reducing the overall MSU consumption on the LPAR or group of LPARs. If the 4-hour rolling average continues to rise, you can see through the examples here, I can take further actions. I can limit the concurrency of jobs, groups of jobs. I can move more work into a resource group. I can move it into a different resource group that's 10%, 5%, 3%, varying levels of constraint. But the general method is that as you get closer and closer to your absolute limit, in this case of 1,000 at capacity level 1, I want to gradually increase the level of constraint because the goal is to flatten out that 4-hour rolling average curve that's heading up in a very sharp slope. I don't want to be going full speed and then come to a sudden stop. That's rather painful. I'd rather just take my foot on the gas and gradually slow down before the concrete wall jumps up in front of me. And this is an illustration of what that looks like. So this is the same chart that we saw at the beginning with the peak versus peak. And we saw that the CPU peak was back at 10 in the morning. The 4-hour rolling average peak of around 300 was about 1 o'clock in the afternoon. And again, I need to start early. So implementing the ACM rules, you can see what happens is, in the bottom chart, long before 1 o'clock comes around, not me, ThruPut Manager and ACM is monitoring the rolling 4-hour average and monitoring the trend. And as it reaches the various capacity levels, which are percentages of my new chosen limit, which in this case is 265, so we opted for a 10% reduction in consumption, very reasonable. It will gradually reduce the selected batch throughout the period shown at the bottom, and this has the effect of gradually flattening out the 4-hour rolling average. So you get this new pink line, which is your new 4-hour rolling average, which actually ends up peaking a little bit earlier. So all the work still gets done, but what I'm doing is flattening that curve, deferring, constraining selected work, while at the same time protecting the critical work. I mentioned earlier that an LPAR can't be in more than one capacity group. It can be in more than one ACM LPAR set. LPAR set is a new concept we introduced just this past year, previous year I should say, for automated capacity management. It's essentially an augmentation of the functions that ACM already has, but what this allows you to do is group LPARs within a machine. And again, this is independent of caps. And one of the key benefits is that you can have multiple, even overlapping LPAR sets. And ACM will calculate the 4-hour rolling average for each set, which could be an individual LPAR, could be a group of LPARs, could be all the LPARs on the machine. But it's going to calculate the 4-hour rolling average for each set and apply your rules with the capacity levels for each set, so they can vary. And let's look at an example of that. So here we have, say, your basic traditional method where I would have an LPAR set for the entire machine. And this is going to simply calculate the overall 4-hour rolling average for all these LPARs combined, and I'll have a limit applied to that, and that's the way that's going to work. In this example, I have an LPAR set. Maybe I'll name it IMS just to keep track of what it's for. And this would only control the 4-hour rolling average on LPAR 1. And based on the relative cost, in this case, LPAR 1 is my most expensive LPAR, I might have a relatively low limit for batch on there. I don't want it to run there unless it absolutely has to run there. For example, it requires IMS. Otherwise, I should run it on one of the others because that's cheaper. I might have a second LPAR set that combines LPARs 2 and 3. Maybe we'll name that one kicks. Both those LPARs run kicks. And again, in this case, I might have a medium limit. These LPARs, the MSUs in these LPARs is going to be less expensive than LPAR 1, but more expensive than LPAR 4. So I want to manage those 4-hour rolling averages independently, and I might very well have different limits for those. Or I can get quite elaborate. In the example here, where I have multiple LPAR sets and I'm combining them, I'm overlapping them. So I have an IMS set, I have a kick set, I have another online set that combines LPARs 1, 2, and 3. So I'll actually calculate the 4-hour rolling average for each LPAR, for each group, such as the kick, and it kicks, and again for the 3 online LPARs. And each of those may have a different capacity level, and the one that's closest to its limit determines the action. And finally, you see at the bottom, I could still have one for the overall machine. What that means is LPAR 4, which is the least expensive LPAR to run on, is only subject to that overall machine limit. So as long as that's not being exceeded, lots of work should go there. This is going to have the effect of greatly improving the cost of your applications by running them on the least expensive LPARs as much as possible. And again, it's automatic. It's with or without caps. So just if you're wondering how well ThruPut Manager automation might work in your shop, send us your data. This is probably the easiest way without even necessarily getting it into a trial of the software. If you send us a month of your SMF 7072 data, we'll analyze your peaks, all your peaks, peak versus peak, for our rolling average and utilization. Common return on investment we find is 8 to 12 months. We will do a presentation with a report of your data showing your potential, and we can go on from there. My email is there. This is just one example of some of the reports that we come up with out of that data. The idea here is that rather than just looking at your peak 4-hour rolling average for the month, which is listed in the SRT report, we're going to calculate your top 50 hours. And the idea being is we're measuring what is the peak and also what is the contribution of batch to that peak. Because let's be fair, ThruPut Manager works with batch. The more batch that's there, the more we can help. The less batch that's there, the less we can help. So on intervals such as the one highlighted here, about 4th, 5th, and right, there's a smaller batch contribution in that interval. So that will be the limit of how much we can reduce that interval. So if we compare that to the original peak, that's where we come up with the estimated reduction at the bottom. But as you can see, when you apply that to a typical incremental rate, we saw the chart earlier, this is at $350 per MSU, significant annual savings, and this is just IBM monthly license charges, so lots of opportunity. Brief summary, CMP is definitely a good idea. I would say, yeah, jump, but not blindly. Obviously, understand your consumption, understand your workloads, evaluate your needs, and most of all, lower your baseline. Definitely look at ways to do that, and we're happy to help when we can. Combining ThruPut Manager, ACM to maximize your monthly license charges savings. Utilize LPAR sets. They're a fantastic update. I love the idea that they can overlap, and I'm calculating all of these 4-hour rolling averages independently. And of course, you can use soft caps. They're fully supported, but absolutely not required. And finally, I'd say see you in Atlanta. Hope you're going to share in Atlanta. If you are, I'll be there, and the rest of the folks from MVS Solutions presenting a few things. Get what you're already paying for. On the second, why did my job run so long? And finally, I think on this particular subject of your share, I would definitely encourage you to come to the final session, which we are just one participant of many. It's a shootout, they're calling it, on ZOS pricing, soft capping, and capacity. And this is myself and other vendors that offer third-party capping products and work in this space. And we'll each get a little bit of time to say, well, here's how our solution works. And then, of course, the audience, you can have at us. So I'm looking forward to that and hope to see you in Atlanta. Just a brief slide about who we are. MVS Solutions, a small Canadian company, the little engine that could. From this, I would say I'm now going to call on my colleague, Nancy DeFilippo. Nancy, who has been at MVS Solutions for a really long time. And do we have any questions, Nancy?
Thanks, John. Yeah, we do. Hopefully you can hear me okay. Thank you to those who have submitted some questions. The first one, John, is simply, won't WLM look after my workloads when soft capped?
That's a great question. I'm glad that one came up, and thank you for asking. That is, I would say, a conception. Certainly WLM will do its best, absolutely. But you have to understand what WLM can see and what it can do and what it can't. WLM runs within the LPAR, and the service class, which determines your dispatching priority, determines which job or application will be dispatched next on the logical processor on that LPAR. So certainly WLM means if you're more important than somebody else, you're wanting to be dispatched on that logical processor first. But WLM has no control over when that logical processor gets dispatched onto a physical core by Prism. And this is, of course, the problem that you run into when you're capped for large periods of time, because Prism simply does not dispatch the logical processor onto a physical core as often. So your application may very well be dispatched by WLM onto a logical processor, and by the way, as soon as it is, it starts accumulating CPU time and service units, which you are billed for, but you may not be actually executing. So just something to bear in mind.
Okay, next, does IRD stop working when you hit the wall and the LPAR group is being capped?
Does IRD stop working? No, if you're using IRD, that's the Intelligent Resource Director. To the best of my knowledge, I'm not an expert on IRD, but it would still try to meet the goals as best as possible within the constraints of the cap by shifting weight around to the LPARs with more important work. But no, I don't believe it actually stops working.
Okay. Our shop is only 153 MSUs, and we did group capping at 113 MSUs. Will TPM be useful for a small shop like us?
Absolutely. And you know, I have to admit, I didn't know that myself until we talked to some smaller customers in the last couple of years. The thing about a small shop, you'd think, well, I don't have that many MSUs, why do I care? But if you go back to that table and you look at the incremental rates, the cost per MSU at a small shop is quite significant. So where the large shops might be saving hundreds and hundreds of MSUs using the ACM solution, a small shop only needs to save a handful of MSUs. We talked to a small shop last year who had an incremental rate of $2,300. $2,300 for a single MSU. That's, you save them 10 MSUs, that's $23,000 a month. That's almost $300,000 a year. So yes, I think is the answer.
Okay. If we have multiple pricing plexes, different predominant plexes, and we are consider combining them, it would make sense to combine before CMP. Is that correct?
Multiple pricing, different predominant plexes. Makes sense to combine them before CMP. I have to think about that. I'm honestly not sure. I don't want to speculate. I mean, essentially, what CMP is going to look at, your current SCRT reports, which are initially LPAR based, but then are rolled up at the CPC or CAC level. So if combining those will affect that resulting number, then yes, I suppose that would be the case. But you know what? I really don't want to steer you wrong. I'm not 100% sure about that.
Okay. How does this interface with CA7, TWS, etc.?
Another good question. The way we like to think of ThruPut Manager logistically is the scheduler sits outside the system, and of course its job is to schedule the work, and it knows when things need to get submitted. And of course the system knows what kind of resources it has, but it has no idea what's coming down the pipe. ThruPut Manager kind of straddles in the middle there. So the work comes in from the scheduler, we go through analysis based on the information that the scheduler quite often can pass us information this can contribute, as well as things that you can put in policy, can determine how important the work is and so on, and then combine that with our knowledge of, well, what is the state of the system right now? What's the current utilization? And by dynamically controlling the initiators and by dynamically resorting the priority of work, we really fit a need that's just not there, because the scheduler will just continue dumping work in, not really being aware of if the system can have it or not. And I guess I would add that there's specifically additional things we can do with CA7 if that's your scheduler of choice.
Okay, the next question is a two-parter. First of all, do LPAR sets, are LPAR sets compatible with group capacity? And secondly, is it compatible with other capping products?
Good question. Yes and yes, short answer. We're absolutely compatible with group capacity, with or without it. And also with third-party capping products. We do have some customers that have looked at those. We have some ones that are actually using it successfully. And we've even tested one of those in-house in our own environment. For those of you unfamiliar, in a nutshell, the third-party capping product will use the standard BCPII interface to dynamically move the defined capacity or group capacity limits that IBM provides for you. And we can absolutely work compatible with those products.
Okay, just a new one came in here. Is there a difference of ThruPut Manager functionality between JES 2 and JES 3?
Very fair question. I have to tell you that ThruPut Manager only works with JES 2, but what I would say about the JES 3 shops out there is, if you are considering moving to JES 2, and I know that sometimes we get these hints from IBM and others that might be a good idea. Should you choose to move in that direction, we do have a JES 3 compatibility component which would save you from rewriting all your JCL. We can absolutely read the existing JES 3 JCL that you have and run that in a JES 2 environment. So that's what I would say on that.
Okay, here's one, John. I'm not sure how you're going to feel about this one, but does ACP, Aggregate Capped Program, apply to mainframe software?
ACP, Aggregate Capped Program. Well, I'll tell you how I feel about it. No offense whatsoever, because I have to be completely honest. I'm not familiar with the term, so I apologize.
Okay. Well, that's all the questions that I have.
Excellent.
So I will pass it back to you.
Thanks, Nancy. If we didn't get to your questions, I would just say, you know, absolutely email us. Emails on the screen here. We'll be happy to get back to you. And I thank you for attending at this point. I'll pass it back to Melanie.
Thank you both John and Nancy for assisting with questions, and everyone online for attending today. As John mentioned, do feel free to follow up with him directly if questions come up throughout the day or tomorrow. You can also direct those to speakers@share.org, and we can follow up with John accordingly. And that concludes today's webcast. We'd like to thank everyone, especially John and Nancy, and the MVS Solutions team for putting together such a great presentation. This feature will soon be available on the SHARE website at www.share.org. Please remember to fill out the survey as you close the webcast. Thank you again for attending, and have a great day.